Good morning, everybody. Hi, I am Vempati Srinivasulu, Assistant Professor of Chemistry, working at Nagarjuna Government Degree College. Today, we are going to discuss about nitrohydrocarbons. Today we are going to discuss about nitrohydrocarbons, which is in the syllabus of BSc second year, third semester. Okay. Then, what are the contents in this chapter? Okay. So, second slide. In this chapter, we will discuss about introduction, aliphatic nitrohydrocarbons definition and examples, classification of these compounds, nomenclature of these compounds, preparation of aliphatic nitrohydrocarbons, reactivity of these compounds, then followed by aromatic nitrohydrocarbons. Nomenclature, preparation of nitrobenzene as an example for aromatic nitrohydrocarbons, physical properties and chemical properties, especially taking nitrobenzene as an example, and reactivity, reduction of nitrobenzene in different media. These are the contents, subtopics we are going to discuss in detail in this chapter. Today we'll discuss about aliphatic nitrohydrocarbons. So, what are aliphatic nitrohydrocarbons? The compounds the organic compounds which are containing NO2 as a functional group. You see, this is NO2 group. NO2 group containing NO2 group is this one. So nitrogen NO2 group as a functional group. Okay. So examples are this is nitromethane, nitroethane, and nitrobenzene, or different examples for nitro compounds. Classification of these nitrohydrocarbons. The general formula of these compounds is RNO2. RNO2. This is RNO2. So depending upon nature of this R group, we'll get nature of the R group is two types. This is nature of the R group. If R is aliphatic, these are called aliphatic nitrohydrocarbons. Whereas R group is in aromatic nature, we'll say these are aromatic nitrohydrocarbons. So, two main classes: aliphatic nitrohydrocarbons, aromatic nitrohydrocarbons. Today we'll discuss about aliphatic nitrohydrocarbons. You see, this is the aliphatic nitrohydrocarbons. So that means the nitro group is attached to aliphatic carbon. So these examples include nitromethane, nitroethane, and nitropropane, etc. So these aliphatic nitrohydrocarbons are subdivided into three types. Once again, that this classification is depending upon the nature of carbon in terms of primary, secondary, tertiary. As as we know that in organic compound, carbons are four types: primary carbon, secondary carbon, tertiary carbon, neocarbon. This classification is based on a carbon which is attached to how many number of other carbons directly. So based on this carbon nature, primary, secondary, tertiary nitro compounds are there. So primary nitro compounds means primary nitrohydrocarbons means in these compounds nitro group is attached to primary carbon. If nitro group is attached to secondary carbon, we can say those are secondary nitrohydrocarbons. If nitro group is attached to tertiary carbon, we call as those are tertiary nitrohydrocarbons. We see in this slide, you see these two are primary. These three compounds comes under primary. You see, so this one is primary carbon, this is also primary carbon, this is also primary carbon. So these three compounds are examples for primary nitrohydrocarbons. Why? This one is primary carbon. You see, this is primary carbon, this is also primary carbon, this is also primary carbon. We see in this example, this is secondary carbon. That's why this is a secondary nitrohydrocarbon. This one primary. This one, you see, is also primary. Okay. Coming to next, we see this example. Okay. So this carbon is directly attached to the nitro group. So this carbon to two carbons. This is also secondary carbon. That's why this compound is also secondary nitrohydrocarbon. So coming to this example, you see this carbon. This carbon is equal to 2 carbons. Once again, this is also a secondary carbon. That's why this is secondary nitrohydrocarbon. Coming to this compound, you see this carbon. This carbon is linked to 1, 2, 3 other carbons directly. That's why this is tertiary carbon. That's why this compound comes under tertiary nitrohydrocarbon. Okay. So this is a classification. So this classification is based on the nitro group attached to which nature of the carbon. Depending upon nature of the carbon, primary, secondary, tertiary nitrohydrocarbons. Next. Okay. You see nomenclature. So we name these compounds as nitroalkanes. Nitrohydrocarbons. If it is alkane, nitroalkane. If it is alkene, nitroalkene. In general, these are named as nitroalkanes. You see, first example. You see carefully. Okay, this is okay. This is, if it is CH4, we call as methane. In place of hydrogen, if we have one nitro group, that's why one nitro group is substituted hydrogen of methane. That's why it is nitromethane. Coming to the second example. This one. two carbons, ethane, but there is one nitro group in the place of one hydrogen at first carbon. That's why it is nitroethane. This is nitroethane. Coming to this compound, you see three carbons, 1, 2, 3. We have to give numbering. So in the nomenclature of organic compounds, we have to follow IUPAC nomenclature. So as per set of rules of IUPAC nomenclature, we have to first identify longest chain, then give the numbering, so that the functional group attached to carbon should get less number. That's why this is 1, 2, 3. So that's why this is 1 nitropropane. Prop means 3 carbons. It's a propane, it's a saturated hydrocarbon. That's why it is 1 nitropropane. Coming to the other example, this one. This one also, what is that? This is also propane. Numbering 1, 2, 3. So the nitro group is at second carbon. That's why it is 2 nitropropane. Okay. Then you see this one. This is longest chain, 1, 2, 3, 4. Fourth carbon. So 4 carbon means butane. But nitro group is at first carbon. That's why it is 1 nitrobutane. You see other example. This is nitro group is at 1 carbon, first carbon, 2, 3, 4, 5. It's a pentane. As we know, that is a pentane. That's why it is 1 nitropentane. So coming to this one, this is also pentane, but our nitro group is at second carbon. That's why it is 2 nitropentane. In this example, it is 3 nitropentane. For example, if there is a chlorine, for example, assume numbering, the name of this compound is numbering 1, 2, 3, 4, 5. 4 chloro, 2 nitropropane it will be. So in this way, we have to name the hydrocarbons, nitrohydrocarbons. So nitroethane, first one is nitromethane, 1 nitropropane, 2 nitropropane, 1 nitrobutane. This one is okay. We forgot this one. We see this one. You see, numbering is 1, 2, 3, 4. 4 carbons. It's a butane. But the nitro group is at first carbon. There is a methyl substrate at second carbon. That's why it is 2 methyl 1 nitrobutane. Okay, this is the naming system of nitrohydrocarbons by following IUPAC rules. Clear? Going to the next slide. Okay, structure of nitro group. We observe carefully. Nitro group is in resonance with 2 forms, with 2 resonating forms. We see electrons delocalization is taking place from oxygen to atom, followed by this one. So due to this delocalization of electrons, we get this structure. So these are in resonance. So that's why they are called resonating structure. That's why you can write a resonance hybrid. This is the resonance hybrid. That means minus charge is electrons charge is delocalized between three atoms, oxygen, nitrogen, oxygen. So in these two structures, nitrogen is containing plus charge. You see, this is a nitrogen plus charge. Okay, this is the resonance hybrid of this nitro group. This is a resonance hybrid of this nitro group. Coming to the next slide, keto-enol tautomerism. So what is keto-enol tautomerism? We know, as we know, we have discussed about keto-enol tautomerism in the previous classes. What are tautomers? Okay, we know that. In this primary and secondary nitroalkanes, they exhibit this type of keto-enol tautomerism. What is happening here? You see the alpha carbon which is attached to the nitro group, first carbon, it has two hydrogens. You see, hydrogen. So this hydrogen is shifting from carbon to oxygen. At the same time, this double bond is shifting from this to here. So proton is shifting to here, double bond is shifting to here. You see, the double bond is shifting to here. So we are observing one new double bond between carbon and nitrogen. So shifting of proton to its adjacent group. In the same time, double bond is shifting. That means shifting of proton and double bond in opposite directions. Then the formed these isomers are called tautomers. So in this form is called nitro form. It is similar to keto form. In the carbonyl compounds, we will observe keto-enol tautomerism. So in the same way, enol form, double bond OH is attached to double bond. That's why we call it enol. But it is not exactly enol. That's why it is called acid form. Because of this hydrogen, it shows some acidic nature. Because of this hydrogen, it shows some acidic nature. That's why it is called acid form. So the alpha hydrogen containing nitro compounds exhibit this tautomerism, similar to keto-enol tautomerism. So not exactly keto, it's a nitro form and a acid form. This is acid form, this is nitro form. So we observe this only in primary and secondary. Why? Only primary and secondary compounds only contains alpha hydrogens, whereas tertiary nitro compound doesn't contain any alpha hydrogen. Thereby there is no shift of proton from carbon to oxygen. That's why those compounds doesn't exhibit keto-enol tautomerism. You see, this is a secondary nitroalkane. Why you are saying secondary? This nitro group is attached to secondary carbon. So this carbon is linked to directly two carbons. That's why it is secondary carbon. That's why it is secondary nitrohydrocarbon. Okay. So what is happening here? Shifting of proton is taking place from here to here. At the same time, double bond is shifting from here to here. So you see, we are observing one new bond between carbon and nitrogen, which is not present in this compound. That's why this is a nitro form, this is a acid form. So that's why we will say that primary and secondary nitro compounds exhibit what? Keto-enol tautomerism. Tertiary nitrohydrocarbons doesn't exhibit keto-enol tautomerism because they are lacking alpha hydrogen. So this is about tautomerism in nitrohydrocarbons. Okay, coming to the preparation. So far we discussed classification of nitrohydrocarbons, and nomenclature. Then coming to the preparation. So we have different types of methods of preparation. In the first example, you see preparation of nitroalkanes from nitration of alkanes. We see in this example when hydrocarbons are treated with nitric acid in presence of high temperature. That's why these hydrocarbons exist in vapor phase. So vapor phase the hydrocarbons which are in vapor phase, when they react with nitric acid, they give concerned nitro hydrocarbons. In this example, we have taken ethane. You see, this is ethane. This is ethane. Okay. See, this is ethane. That's why this is nitroethane. Okay. So, nitrohydrocarbons. In this second example, if you take propane, this is a propane. You see, this is a propane. When propane is treated with nitric acid at higher temperatures, we expect two types of compounds. We see mixture. We are getting mixture of compounds. One is you see one is 2-nitropropane. Second is 1-nitropropane. We expect these two compounds. We are getting two more compounds which are obtaining as byproducts nitroethane and nitromethane. What is happening here is cracking taking place. The fission of carbon is taking place at higher temperatures, and further we have nitric acid. So in presence of nitric acid, fission taking place. Okay, at hydrocarbons. So this is one method. What is this? Vapor phase nitration of alkanes. When alkanes are treated with nitric acid at higher temperatures, it gives nitroalkanes. If it is a hydrocarbon has more number of carbons, long chain hydrocarbons, it undergo cracking. That's why we're getting mixture of these compounds. Okay, this is one method, preparation of nitroalkanes with nitric acid at higher temperature. Coming to the next method, you see preparation of nitroalkanes from alkyl halides. You know what are the alkyl? The halogen containing hydrocarbons. So when alkyl halides, when we treat with the silver nitride on heating, we'll get nitroalkanes. In this example, it is ethyl halide. You see, this is ethyl halide. Halide means X. In place X, we can take chloride or bromide or iodide. Okay, if we take silver chloride, ethyl chloride, we get nitroethane and silver chloride. In general, alkyl halides, when react with the silver nitride, they will give corresponding nitroalkanes. Okay, if you take ethyl chloride, we'll get nitroethane. If you take propyl chloride, we'll get propyl nitropropane. You take 2-bromopropane, we'll get 2-nitropropane. So in general, alkyl halides, when they react with this AgNO2, will get concerned nitro compounds. Third method, from alpha halocarboxylic acid. So carboxylic acids are the compounds which contain COOH as a functional group, as we know that. This carboxylic acid, when it contains a halogen at alpha carbon, we call as alpha halocarboxylic acids. So for example, this one is a alpha chloroacetic acid, 2-chloroacetic acid. When this alpha chloroacetic acid or alpha chloroacids, when we have sodium nitrite NaNO2, NO3 is nitrate, but this is NO2. Okay, so this is NaNO2. We'll get what? This one. Nitro alpha nitroacetic acid. Okay, alpha nitroacetic acid. Okay, so alpha chloroacetic acid on treatment with sodium nitrate, it is giving what? Alpha nitroacetic acid. You see, this one is alpha nitroacetic acid. This is alpha nitroacetic acid. Okay, coming to the next slide. Coming to next slide. You see, what is happening here? Okay, from previous slide, we'll go previous slide, 9th slide. What is 8th slide? Okay, this is okay. Video. My 12th slide. We need only 8th slide. Okay. Okay. So what? Okay, we are prepared. We are discussing about preparation. This is over. I think this one. Okay. No, this is also over. Okay. Oh, and this one. Right. You see, this is over, right? Okay. Okay. Oxidation reaction of amines. The tertiary amine is a tertiary amine. The IUPAC name is 3 tertiary butyl primary amine. That means 2-methyl 2-aminopropane, or we call as tertiary butyl amine. So when this tertiary butyl amine is treated with potassium permanganate like highly oxidizing group, it is converting into nitro group. You see what is happening here? You see, amino group is converting into nitro group. Okay, so amines are converting into nitrohydrocarbons. So in presence of strong oxidation like potassium permanganate. So amines on treatment with the potassium permanganate, they are converting into corresponding nitro compounds. This is one method of preparation. Okay, tertiary amines are converting into tertiary nitro compounds. Why we are telling tertiary? You see, in this example, this nitro group is attached to tertiary carbon. Why tertiary carbon? It is directly added to 1, 2, 3 carbons. That's why it is tertiary nitro hydrocarbon, tertiary butyl nitro compound. So tertiary butyl uh, nitro compound. The name of this compound is 2-nitro 2-methyl propane. So this is preparation of one of the preparation method of nitro compound. Okay. Then one more slide. Next slide. Okay. Then you see chemical properties of nitrocarbons. So far we discussed about preparation of nitro compounds. What are those? From hydrocarbons directly with nitric acid. Second, from halogen compounds. Third one, from alpha halo acids. Fourth one, from amines. Now we discuss chemical reactivity of these compounds. We see halogenation. First reaction is halogenation. So primary and secondary nitroalkanes easily undergo halogenation at alpha carbon in presence of alkali solution. Whereas tertiary nitrohydrocarbons doesn't exhibit this type of reaction. Especially it doesn't undergo halogenation at alpha carbon. Why? Because there are no alpha hydrogens at this carbon. There is no alpha hydrogens. That's why only primary and secondary nitrohydrocarbons only exhibit this type of reaction. You see, for example, we have taken nitroethane, bromine as halogen in presence of alkali in OH. It is giving what compound? You see, it is a one bromo nitroethane, one bromo, one nitroethane. Further bromation is giving dibromo compound. Why? Because there is one more alpha hydrogen. So primary hydrocarbons contains two alpha hydrogens. That's why two hydrogens replaces by bromines or halogens. So this is one example. One more example. For example, nitromethane on treating with the chlorine in presence of NaOH. So monochloronitromethane, dichloronitromethane, finally trichloronitromethane. You see, all chlorines are replaced by, or hydrogens are replaced by chlorines. This is called trichloronitromethane. This is also called chloropicrin. This general name of common name of this compound is chloropicrin. So trichloromethyl 1,1,1 trichloronitromethane. The base now this compound is like this. So this is halogenation. Okay, we'll go to next slide. reaction with the nitrous acid. In the previous reaction method, we discussed hallucination. In this reaction, we'll discuss about reaction with the nitrous acid. What is nitrous acid? HNO2. HNO3 is nitric acid. HNO2 is nitrous acid. We see this is nitrous acid. This reaction, that means nitroalkanes with the nitrous acid, we call this reaction is white, blue, red reaction. Why? So first, primary nitrohydrocarbons, when they react with the nitroalkanes, nitrous acid, they'll give nitroso compound. Is it NO group is nitroso. So nitroso substituted nitroalkanes. These compounds exhibit in blue in color. Okay, this blue compound once again react with the NaOH. That means dissolved in NaOH, giving red compound, sodium salt of this nitroso compound. What is happening here? This nitroso containing nitro compound undergo ketoenol tautomerism. This you see, this one is enolic form. So because of having this acidic hydrogen, it easily dissolves in strong base like NaOH. Whenever acid reacts with the base, it gives salt. You see, this is a salt of NaOH, sodium salt of this compound. So that's why primary nitrohydrocarbons, when they react with nitrous acid, they give nitroso substituted compound. This nitroso substituted compound, which obtained from primary nitrohydrocarbon, easily dissolves in NaOH by giving a red solution. So blue solution changes into red solution in presence of NaOH. This is happened in the case of only primary nitrohydrocarbons. So coming to the secondary, you see this is secondary, isn't it? It is secondary. How can we say secondary? You see this nitro compound is attached to this carbon, nitro group. It is secondary carbon. So secondary carbon contains only one hydrogen. So that's why secondary nitro compounds having only one alpha hydrogen. So this secondary alkane, when it reacts with the nitrous acid, it gives pseudo nitrolic acid. That means same. It is in this case, this alpha hydrogen is replaced by nitroso group. Okay. There is no alpha hydrogen. There is no one more hydrogen. Only one hydrogen we have, that is replaced by nitroso. That's why this doesn't exhibit any tautomers. That's why this doesn't dissolve in what? NaOH. So this is only, it gives only red solution. Blue solution, no red solution. So okay. Whereas coming to tertiary compound doesn't react with the nitrous acid. No reaction. So in general, what we know is only primary and secondary nitrohydrocarbons only react with nitrous acid. Tertiary doesn't react with nitrous acid. Whereas primary nitrohydrocarbons, when they react with nitrous acid, they will give first nitroso substitute compound, nitrolic acid, which is in blue color. This blue color changes into red color in presence of addition of more NaOH. So finally we get red solution. In the case of secondary nitrohydrocarbon, this reaction takes place in one step only, no second step. Why? Because secondary nitrohydrocarbon doesn't have two hydrogens. It has only one alpha hydrogen, which is substituted by nitroso group in the first step. this is not soluble in NaOH because it doesn't have any enolic hydrogen. So, whereas tertiary, no reaction at all. That's why this reaction is called white, blue, red reaction. It's a very important reaction. So many times it is applied in the examination. What is a white, blue, red? Why we call it white? Tertiary nitrohydrocarbons doesn't react with nitrous acid. So it remains as such, colorless or white. Whereas primary, it gives first blue color followed by addition of NaOH. By dissolving NaOH, it forms salt of the compound, which is in red color. So whereas secondary, it gives only blue color, no coloration, red coloration. So that's why by using this reaction, we can easily differentiate primary, secondary, tertiary nitrohydrocarbons. Okay, so this reaction is used to differentiate primary, secondary nitrohydrocarbons. So today we close this chapter. What we have learned today? What are nitrohydrocarbons? Classification, then followed by nomenclature of nitrohydrocarbons. We explained with the different examples. Then preparation of nitrohydrocarbons by 3 methods, and chemical reactivity. We learned hallucination and reaction with HNO2. So we thank you very much. We are closing this chapter here.